Assalamu alaikum. Today's topic is angular dispersion and dispersive power. In previous lecture, I have explained you the dispersion and cause of dispersion. That means splitting of white light into band of 7 colors is called dispersion. If you remember the previous lecture, we have seen that band of 7 colors is formed. It is because of different wavelengths. Since I have shown in the previous lecture, violet has the least wavelength and red has the most wavelength. That means it depends upon the wavelength. The wavelength which is having more wavelength suffers least and violet suffers the most. That means all the colors suffers the deviation between red and violet. I have discussed in the previous lecture. The two extreme colors are here, violet and red color. Violet and angular dispersion is defined as the difference in deviation. If I define angular dispersion, and then I will try to explain it also. It is asked 2 marks sometimes, question 2 marks. Angular dispersion is defined as the difference in the deviation suffered by the two extreme colors. Two extreme colors are red and violet. In passing through prism. That is the angular dispersion. If you look toward, if I make a diagram here, suppose this is the prism here. This is the incident ray here, and when the white light is passed through the prism, it splits into colors of 7 colors. As you look towards the diagram I have discussed in the previous class, it separates into 7 colors, and these 7 colors are, as you know in the previous class, these are violet, indigo, blue, green, yellow, orange and red. Here if you look towards this is the indigo, this is the red, and all the colors, remaining colors, suffer deviation from between red and violet. That means if I take only two, because angular dispersion is the deviation supported by two extreme colors, मुझे सिर्फ रेड और वायलेट यहाँ लेना है. Suppose that means it gets here. If I make a diagram here, I take only 2 colors here. Sorry, it's refracted. This is one deviation. Suppose this is red color and this is violet. That means the deviation of red color is from this to this. This we can write delta R. That is, this is the deviation in the red color. This is the deviation in the violet color, delta V. The difference of these two, that means this is delta V is its whole deviation in violet color. This is delta R. The difference of these two, this it is called delta V minus delta R. This deviation is called angular dispersion. That means angular dispersion is equal to angular dispersion, angular dispersion. Sometimes we write theta is equal to delta V minus delta R. I hope you have got this in this. This is the white color and it is split. I am taking only two colors. This is the deviation in the red. This line is the deviation in the red. This is the deviation in the violet. The deviation is red is actually from this was the light. It will travel in this direction. This is the deviation in the red. This is the deviation in the violet. The difference of these two is the called angular dispersion. Hence, expression of angular dispersion in terms of mu and a. Mu is the refractive index, a is the angle of prism. That means I can write angular dispersion theta, or we can write the deviation of extreme to extreme color go delta V minus delta R in terms of mu and a. Expression of theta, or theta can be written as delta V minus delta R in terms of, that means angular dispersion in terms of mu is the refractive index and a is the angle of prism. The deviation produced by small angular prism. If you remember the deviation produced by small angular prism. If you remember in the previous class we have discussed deviation is equal to mu minus 1 into a. But here the deviation for red color, red color delta R, that means the refractive index of red minus 1 into a. For violet color, for violet color, how can we write? We write simply delta V is equal to mu V minus 1. But angular dispersion is equal to delta V minus delta R. We can subtract these two equations, subtracting equation first from equation second, we can get subtract. When we subtract equation first from equation second, we can delta V minus delta R is equal to, instead of V I can write mu R minus 1 into a minus, instead of, it is V, sorry, it is V mu V minus 1 into a. Instead of delta R I can write mu R minus 1 into a. If I solve this, it will mu R minus a minus mu, it is mu V minus a, mu R minus mu R plus a. This plus a and this cancel out, but this a is the multiplier of both. We can ultimately give mu V minus mu R multiplied by a. This is the angle, this is the angular dispersion in terms of mu and a. That means mu V minus mu R into a is also called angular dispersion. One more term which is asked in this, that's called dispersive power. This is 2 marks question. Dispersive power. How can we define dispersive power? Dispersive power is connected with the dispersive power. It is it is defined as the ratio of angular dispersion to the mean dispersion. It is defined as the ratio of angular dispersion to the mean deviation produced by the prism. That means it is the ratio of angular dispersion to the mean deviation produced by the prism. That means it is represented by W, angular dispersion. Dispersive power. It is omega, just like omega. That means omega can be written as this angular dispersion, that is theta divided by mean deviation is equal to this. This is the this can be written as delta v minus delta r, because this is the deviation supported by two extreme colors divided by delta. That means angular dispersion is equal to delta v minus delta r divided by delta. We can also write in terms of mu and a, because instead of delta v we can write mu v minus 1 into a minus, because delta v is equal to mu v minus 1 into, for small angular prism. Just like delta r is equal to mu r minus 1 into a, deviation is equal to mu minus 1 into a. This can be written as this minus a and plus a, it will cancel. We can write mu v minus mu r into a divided by mu minus 1 into a. I hope you have got it. I will repeat. Delta v is equal to mu v minus 1 into a. Delta r is equal to mu r minus 1 into a. Deviation is equal to mu minus 1 into a. यहाँ minus a, this plus a, this will cancel each other. Mu v minus mu r, a तो common है इसका, and a will cancel. We can write this dispersive power mu v minus mu r divided by mu minus 1. This is the dispersive power in terms of refractive index. I hope you have got it. Sometimes these are asked 2 marks or 3 marks question. 2 marks, small type of questions are asked, and sometimes numericals are asked on this angular dispersion and dispersive power. I hope you have got it. Hope we will meet in the next class. Thank you very much.